We're going to start talking now about graphing all of these quadratics that we've been worrying about in this last chapter with factoring and taking out greatest common factors and double bubble and trying to use the grouping to help factor these. Now we're going to start looking at graphing. So we've done a lot of graphing this year. We did graphing at the beginning of the year with linear equations where we had the perfect straight lines. We talked about exponential graphs where we saw those kind of half curves where they kind of approached a number but then went sharply with the exponents. But now we're going to start talking about quadratic functions. The quadratic functions we've been seeing, now we're going to look at what they look like on a graph. And then we'll kind of go through this chapter and see what kind of things are being told about them. So some important facts about the quadratic functions. So quadratic function, it is a non-linear function. So we definitely are not going to see straight lines. We're going to see a different pattern that we'll talk about in a second. It is written in the form, the standard form of these is y equals ax squared plus bx plus c. Now remember in the last chapter we were factoring things that looked like this. Now we're just going to start trying to graph them and see what they look like on a graph. The graphs that they're going to present to us are a U-shaped graph. They look like a U and you'll see some in a minute. These are called parabolas. P-A-R-A-B-O-L-A. That is called a parabola. The highest or the lowest point is called the vertex. And we'll use this to compare a lot of different things to finding what this number means and what it actually is. And there's a line that splits our U parabolas in a perfect half where we have two equal sides. And this is called the line of symmetry. Or we see it called the axis of symmetry. So either of those is the same. It's the axis of symmetry or the line of symmetry. So next we want to talk about the different characteristics of these functions, these quadratic functions. We see a graph here, which is showing us the parabola we just talked about, this U-shaped graph showing us that this is not linear, this is not exponential, it definitely is a quadratic. We want to talk about these different characteristics. So first, the vertex, from up above. The vertex is my lowest point. So right here, this is the lowest point of my graph. Now, if this was going down and turning downwards, this would then be the highest point, but it still would be the vertex. The vertex is either the lowest or the highest point. So the vertex, I just take the point right off the graph. The vertex is sitting right there at 2, -3. The axis of symmetry. So the axis of symmetry is really not a piece that I see on the graph. The axis of symmetry, though, is an imaginary line that is an important part, but we don't really see it. But basically, this would be my axis of symmetry. It would be this imaginary line cutting through my parabola so that I have that mirror or symmetrical shape on both left and right sides. So to write this, I'm basically writing the equation of that line. So remember way back from the beginning of the year, a vertical line is written as x equals, and where is it crossing with the x value? X's are always 2. So x equals 2 would be the axis of symmetry or line of symmetry. Domain we've talked about in the past. Domain is what are the numbers that we are able to plug in. Those are our x values, remember? And in this case, we don't have any restrictions. We can plug anything we want in to see what comes out. So this would be all real numbers with that notation if we want to use that. All real numbers is good there. The range, remember on range, those are our y values. So the y values mean, looking at my graph, what are the y values for all these points that we're seeing here? What are all the y values going to be? Now we certainly can see things at -3. At -2, at -1, at 0. These arrows mean it's going to keep going upwards. So when I put down my range value is going to be y is greater than or equal to -3. -3 is the lowest y value we will ever see, and then they will be increasing and above that at that point. And then these next two parts, increasing and decreasing. So increasing. When I look at the increasing, my graph is going down, which is decreasing, until I hit this point, and then it's increasing from there on out. So basically all I'm going to really say there when I'm looking at the increasing part is this graph is increasing when x is greater than 2. It is then climbing in y values, so the increasing part are the y values. The decreasing part is happening over here on the left-hand side when x is less than 2. So increasing and decreasing, that's telling us where we're seeing it happen on the domain, which is x's are greater than 2 and x's are less than 2. So now we want to talk about graphing and using the f of x, ax squared. Remember, that is the parent function. We talked about a parent function. That's kind of the one we always compare lots of things to. When we did our linears, we talked about y equals x, y equals ax squared. When a's are greater than 0, are going to be the one that we're going to be comparing most of these to. Okay, so when we talk about the parent function, the parent function is right here, the f of x equals x squared. So to graph my g of x function first, which is 2x squared, we're going to make a table. So back when we did linears, we said we need at least 3 points to prove that we saw a nice straight line. When we did our exponentials, we said we need to kind of see it leveling off and approaching a number. So we said we probably needed about 5 numbers. In this case, we're going to start out with tables, and we're going to start out seeing definitely 5 numbers, and then we're going to kind of hopefully learn some throughout this chapter where we can kind of help streamline a little bit. Okay, so we're going to make a table. So when -2 goes in, we're going to get -2 goes in. We just figure out, well, what does that come out to be? -2 squared is 4, comes out as an 8. When -1 goes in, I get 2. When 0 goes in, 0 to the second power, 0 times 2 is 0. When 1 goes in, I get 2 again. That's important to notice, and we'll talk about that in 1 second. And when I plug 2 in, I get 8. So as we are making these tables, there's an important thing that we want to start noticing. Notice how our y values went 8 to 2 to 0 to 2 to 8. This right here is telling us something really important, as we have now seen when we've reached the lowest point and we've started to see duplicates of the y values. That tells us that we've basically seen the u happen. So we want to graph this y equals 2x squared. So y equals 2x squared. When I look at the y's, I get -2, 8. And I'm actually going to pause this, draw this. You can do the same thing. And there's the graph. Not a great graph, I get, but what you want to really do is think about making a nice rounding as you approach that vertex so that you don't get a V. It's not perfectly sharp. It's a rounded as you get close to the vertex and then goes back up. So then they asked us to compare this to the graph of f of x is x squared. Well, we kind of first need to know what that looks like first. So if I go through that same thing and make my graph, I would have x squared, so -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is just like -1 squared, and 2 squared is just like -2 squared. And again, notice that we have that rounded at the 0, we get the 1 on both sides, then we get the 4 on both sides. So I'm just going to pause this to draw that, and you do the same. It's an ugly parabola, but that's hard to do these on these iPads, so I apologize for that. But what I do want you to notice here is, remember when we do all this from the past with the absolute value functions, remember when that number in front of the x squared is bigger than the 1, it's actually making this thing close. So when we did the absolute values and we had that number that was greater than 1, it kind of closed the V. It's the same thing here, as our u is now vertically shrunk because the 2 is bigger than the 1 that's in front of the x squared. So it's definitely more of a u that's tighter on the inside than the one that is the parent. So when we talk about comparing this, so how do we compare this? There's a couple of things we want to look at. So we want to talk about, well, how do the vertex compare to each other? Well, they're the same. They're both 0, 0. So same vertex. What's about the axis of symmetry? We're going to use AOS as the axis of symmetry. They are both the same also. Obviously, there's a distance difference between the two different ones from their own axis of symmetry, but their axis of symmetry for both of them is the same. X equals 0. Then the only other thing we want to mention is that how do they open? They open both up. So there's a lot of things that are the same about them, but one of the things that's not the same about them is that g of x opens more narrow than the f of x. They call that a vertical stretch. But basically, when you look at it, it's more of a narrow, just like with the absolute values, you saw a more narrow v when the a in front was greater than 1. In the same case here, when it's greater than 1 for that a value, you're going to see your u, or your parabola, more narrow than the parent function, which has a 1 in the front. Next, we want to talk about another one when the a in the front is now less than 0. So when we have the a out in front, it's going to be very similar to when we saw the absolute values, but let's just run through it so we can make sure we completely understand. So just going through and filling out our table. So we have negative 1/2. If negative 2 goes in, when you square negative 2, you get 4. 4 times a negative 1/2 is a negative 2. When I plug in the next one, negative 1 squared gives me positive 1, which now makes this a negative 1/2. Same idea when I do this 0. When I square it, it becomes 0. The whole thing is a 0. When I plug in the 1 and square it, I still get the negative 1/2. And this last one over here, if I plug in a 2, I get 4. And when I square that, I still get negative 2. And again, we can see how we did start seeing doubles of our y values, which shows that we've reached the bottom or the top, and now we've kind of seen it kind of come back around. So the first thing I'm going to do here is I'm going to pause the video, and I'm going to do a quick graph of this parent function, f of x equals x squared, so that we can see what that looks like. And then I'm going to we'll talk about that quickly, and then we'll go to the next graph. So there's the parent function, and again, not perfect, but it's difficult on these screens. So now we want to do the other one so we can see what this one's going to look like. So again, I'm going to pause the video. You're just going to plot those 5 points and draw your nice smooth curve and see what you can come up with. Well, hopefully you have something that looks like this. We have something now that's still a parabola. We did see that line of symmetrical piece going there, but we now do definitely see some different values. We obviously are seeing the u going downwards versus going upwards. So compare to that first graph. So again, the major pieces, the vertex is the same. They are both at 0, 0. Axis of symmetry, it is also the same. Even though one's opening up and one's opening down, we still have x equals 0 as the axis of symmetry. Now, the h of x opens downward, and hopefully we all can understand why that's happening, because we saw that negative a in the front, just like we saw with the absolute value functions back at the beginning of the year. And then lastly, we want to talk about the width. So h of x. Because this number in the front is between 0 and 1, it is going to be wider, so it's going to open wider than the f of x. Okay, that is called the vertical shrink. It's not as tall, takes longer to build up, but it's opening wider. So when you have that number that is between 0 and 1 in front, it opens wider. When it's a negative, it now opens downward. So here's just a kind of a graph, just kind of showing, I know it looks a little wild and crazy, but it gives us an idea of what we just kind of already shown and proved. When we have the a is greater than 0, we talk about how they're all opening upwards. When the a is less than 0, they're all opening downwards. The vertical shrink is happening when we have a number between 0 and 1, either on the positive or the negative. We have a vertical stretch when it is a greater than 1. So anytime you see those things, we just proved it on a couple of graphs. This is showing you a good diagram of what we just talked about. And lastly, what I want to talk about today is how do we solve a real life problem. So obviously in real life, you wouldn't see this satellite dish on a piece of graph paper, and obviously we do have a piece of graph paper, but basically what we're just trying to find out here is how we can use this kind of parabola look. We have this U look here to find the width and the depth of the dish. Now, there's lots of different ways we could do this without the dish and all the rest of that on a graph paper, but just to kind of get an idea of where we can start seeing this. So the width is kind of the easy one. So if I look at the width and I use the graph paper, the width is from here all the way across to here. So if I start over here, which the x's are -2, I would travel 2 to the 0, 2 out to the other side. So that one's pretty simple. So we're going to have 4 meters across of this cross section. Now, how do I find the depth? Well, there's a couple of ways I can find the depth. Yes, I can also use this same idea and say, oh, well, I can see the depth goes from 0 to 1. So the depth is 1 meter. So that kind of shows us the characteristics of these quadratic functions now that we're looking at them as far as graphs. So we're going to get back to the factoring stuff as we keep going through chapter 8, but we're going to really focus a lot more on graphing for this chapter to kind of see how all these characteristics translate onto graphs and how we can use the different parts of them. So the important parts I think today to make sure we are comfortable with is vertex is the highest point or the lowest point of our parabolas, which are the U-shaped parts of these graphs. We also want to talk about that axis of symmetry. We want to see the exact same thing happening on the left side of the vertex and line of axis of symmetry as we see on the right-hand side. So we're going to be kind of building on this very quickly over the next couple of lessons because I think the next one builds very easily and the next one builds off of that to get to the more complex ones right away. So really make sure you're focusing on it. Be very careful with your tables. Make sure you're following your exponent rules and order of operations correctly. And also make sure that you are using at least 5 points so that you can see the U happen when you make your graphs. Hope this really works, and I hope this is kind of makes some sense. And if it doesn't make sense, please let me know, and we'll be happy to go through it in more detail.